Introducing SmartX HCI in 360 seconds. With digital transformation in full swing, the IT infrastructure department is facing multiple challenges. While ensuring the efficient and stable operation of core applications is one priority, rapidly spinning up modern applications is another. However, legacy architecture and storage arrays are typically difficult to operate and maintain and require a significant initial investment. They are space and time consuming during initial setup and future scale-up, unable to support investment on demand and quick workload launches. The rise in hardware numbers often comes with an increase in investment and management complexity. Public clouds have superior elasticity and flexibility, but fall short in data security. How do you build a modern on-premises IT infrastructure that supports investment on demand, just like public clouds, is easy to operate and maintain, and can support various applications? SmartX HCI addresses these challenges with 4 critical capabilities. Capability 1. Investment on demand and quick resource allocation. Compared with legacy IT infrastructure, SmartX HCI drops the dedicated hardware-based storage arrays and replaces them with SmartX Distributed Block Storage (ZBS), which is based on industry-standard servers and Ethernet switches. It then converges distributed block storage and compute virtualization into the same node. You can start from only 3 nodes and easily scale out as your business grows. Storage and compute resources can be increased online and distributed flexibly within clusters. HCI supports investment on demand and quick resource allocation, just like public clouds, while ensuring data security, simplifying infrastructure, and reducing server room space. It is more suitable for you to build on-premises infrastructure. Capability 2. Support multiple hypervisors and hardware. To deploy SmartX HCI, you can use VMware ESXi in conjunction with SmartX Distributed Block Storage (ZBS) and continue with your current management, or choose the production-ready and free SmartX native hypervisor ELF to reduce costs. With SmartX Migration Tool, you can easily migrate your virtual machines across platforms. SmartX HCI provides software that runs on industry-standard servers, giving you flexible options and allowing you to reuse existing servers. You can also choose our all-in-one HCI appliance, an out-of-the-box and easy-to-use product for more convenience. Capability 3. Support mission-critical applications. SmartX HCI ensures business continuity and data reliability for your critical business from every angle. From data checksum for HDD, multiple replicas for node, rack-level high availability, to active-active cluster for data center, and cross-site replication. With a fully distributed architecture and end-to-end optimization and virtualization, cache, and network, you can now achieve the same performance as traditional storage arrays with a few nodes, and even higher performance by adding capacity. Through micro-segmentation of our network and security feature, you can easily build a zero-trust infrastructure to reduce the impact of security threats on business continuity. So far, 69% of SmartX HCI nodes are deployed in production environments of financial services and other industries, supporting core databases and critical business applications. Capability 4. Intelligent operations and maintenance with zero downtime. With simplified architecture and intelligent features, SmartX HCI helps reduce IT management complexity and human error, and ensure continuous infrastructure upgrades. This is made possible with zero service disruption during scale-out and software and hardware upgrades, zero manual operation and automatic data recovery and data rebalance after scale-out, one click in resource utilization, log collection, and other operations, and one interface to manage multiple clusters and data centers. With these 4 critical capabilities in combination with our professional service and support, you can build a modern IT infrastructure that simplifies the entire IT lifecycle, including planning, configuration, deployment, operation, and O&M management. Over 10,000 SmartX HCI nodes have been deployed globally in financial services, healthcare, manufacturing, retail, and other industries, For 2 consecutive years, we have been ranked number 1 in HCI software market of financial services in China and named Asia Pacific Customer's Choice by Gartner Peer Insights. As a critical part of the hybrid cloud, SmartX HCI is widely deployed among large and mid-sized enterprises to build various resource pools to support critical business, modern applications, VDIs, robo, and so on. It also helps small and mid-sized businesses build modern IT infrastructure with proven stability, simplicity, flexibility, and desirable cost performance to support various applications. If you need help with IT infrastructure upgrades or HCI product selection, don't hesitate to contact us. You can also visit smartx.com/global to download our free community edition and join the SmartX community for technical support. Begin your HCI journey right away with SmartX HCI.
Hi everyone, I'm Anne, Brand Manager at SmartX. Thank you for joining us in today's webinar. SmartX HCI version 5.1 is a big update from the last version, and with the updates, it has become the de facto full-stack HCI for both virtualized and containerized applications in production. And I'm excited to welcome you all today to find out more about the new features and improvements. So today's webinar is going to include 2 sessions. Edward, our head of product, will introduce SmartX HCI in detail, and Muyuan, our sales engineer, will demonstrate some of the most important new features. The live discussions and the Q&A will take place in our Slack community channel. So before we start, I invite you to click the link in the description to join us on Slack, where our experts will answer your questions. And the slides to use today will also be shared in the community after we finish. Okay, first, let's welcome Edward to give us a detailed introduction to SmartX HCI 5.1.
Hello everyone, this is Edward, the product manager at SmartX. It has been a year since the last webinar. I wonder if you have used our products and if you have any feedback. We have released a lot of features and products over the past year, and I'm really excited to have the opportunity to share all of them with you today. Let's start by taking a look at our progress in marketing. Over the past year, we have been continuously gaining recognition from leading research companies such as Gartner, Forrester, GigaOm, and IDC. According to IDC's latest report, we currently rank the top 1 in the pure-play HCI software market in China. In Forrester's most recent HCI Wave report, we are recognized as a contender. And in GigaOm's HCI Radar report, we've earned the title of fast mover. Furthermore, Gartner has acknowledged our strong support for multiple hypervisors and containers, as well as our high-performance storage solution, designating our product as a recommended server virtualization brand along with another 20 global vendors. Meanwhile, we have been earning more recognition from our customers. We have now deployed over 15,000 nodes across 1,000 clients, spanning various industries such as finance, healthcare, and manufacturing, etc. And we have provided stable support for their systems, including banking, HACE, math, ERP, and database, etc. And now, let's come to the products themselves. This picture displays all the products we have released, including hardware, virtualization and storage, network and security, data protection, container, and management. First, in terms of virtualization and storage, a number of new features have been released with SmartOS 5.1, and its performance has been doubled. As for network and security, we have introduced the load balancer and are about to launch VPC to help users establish a purely software-defined networking system. Regarding data protection, we have released backup and disaster recovery, a product that supports data replication across multiple clusters and offers various disaster recovery features. Concerning containers, we have released SmartX Kubernetes service, which enables users to easily build Kubernetes workload clusters. Lastly, in relation to the management, we have optimized observability, allowing users to visualize network traffic in a more direct and convenient way. Next, I will provide a detailed introduction to these new products and features, as well as the enhanced performance, reliability, security, and simplicity that they bring to our users. Firstly, we prioritize the higher performance. Since many mission-critical applications such as database and banking systems run on SmartOS, we have been continuously improving performance to ensure that we can support the stable operation of these systems. This diagram illustrates the overall architecture of our hyper-converged system. With the release of SmartX 5.0, we have already achieved excellent performance through distributed architecture, I/O localization, automatic querying of hot and cold data, boost mode, and RDMA. In version 5.1, we have further optimized the storage engine, which achieved a nearly double storage performance. Even with the medium cluster configuration of just 3 nodes, we can now achieve 1.38 million random read IOPS and 19.3 gigabytes per second sequential read bandwidth. It's important to note that this class just uses a hybrid configuration, with each server equipped with only 2 NVMe SSDs, which is very cost-effective. At the beginning of this year, with the emergence of LLM such as ChatGPT, the AI quickly became the focus of everyone's attention. Therefore, we also supported GPU to help users run AI, machine learning applications. Users now can choose the corresponding GPU card based on our compatibility list and quickly build an AI infrastructure. As mentioned above, many applications running on our systems are database. In addition to relatively high storage performance requirements, such applications usually also require stable CPU resources. Therefore, we provide the vCPU-pCPU pinning function, which can pin the vCPU of the corresponding virtual machine to the physical CPU to prevent other VMs from competing with it for CPU resources. From the test data, we can find that after vCPU-pCPU pinning, the performance of the MySQL database is increased by 50% on average, and the latency is reduced by 50%. In terms of networking, in addition to virtual networks and SRIOV, we now can pass through PCI NICs to virtual machines to obtain the best performance comparable to physical NICs. Next, let's talk about higher reliability. Firstly, we have optimized one of the most critical virtualization features, VMHA, reducing its completion time by 50 seconds. In case of a physical host failure, we can now rebuild the virtual machine on a healthy host in just 130 seconds. Additionally, we have introduced backup and disaster recovery 2.0. This feature enables asynchronous replication of VMs from one hyper-converged cluster to another, facilitating prompt recovery when needed. It's agentless, and with the Cloud Tower management platform, users can conveniently manage everything by a single interface. Building upon replication, we also provide disaster recovery capabilities, helping recover the application as quickly as possible. After replicating the source VM, a replica VM will be created in the target cluster. When performing failback, we can choose to configure the boot sequence and time intervals for multiple replica virtual machines belonging to the same replication plan. Additionally, we can define IP mapping rules for each virtual machine, ensuring faster recovery based on specific business requirement and minimizing RTO. During the recovery process, we also provide two options, failback and permanent failover. In the failback process, the data of the replica VM in the target clusters is synchronized back to the source VM. It's a good choice when your source cluster is still functioning, but the virtual machine itself is unable to be restored due to a fault. On the other hand, permanent failover lets the replica VM seamlessly take over as the original, stepping in when the source cluster experiences a total failure that cannot be recovered. Now let's proceed to the updates on networking and security. In the past, we believed that as long as we could secure the north-south traffic, the entire data center will be safe. However, the development of ransomware and cyber attacks have made it clear that data centers are also facing security threats from the inside, and that's where Everroot comes in. It's agentless and provides users with virtual machine east-west traffic protection through micro-segmentation technology. After we group VMs by labels, we can configure fine-grained security policies for them and start to protect their traffic. To demonstrate how Everroot works, let's take a typical web application as an example. With Everroot, we can segment web servers, API servers, and databases using labels and only open specific ports on each segment. This guarantees that different services must communicate with each other according to our specific rules, while all unauthorized communication will be rejected. Now we are moving on to simplicity. When building IT infrastructure in private data centers, simple maintenance is crucial. We understand that our users may not have enough resources or manpower to handle complex maintenance tasks. That's why we have been continuously optimizing our operation-related features to make them simple, flexible, and intelligent. The first feature we launched is VM resource optimization. I believe that every administrator often encounters such a problem. The owner of a VM always applies a VM with very large specifications, such as 32 cores and 128 GB memory, but he does not actually need so many resources. This VM may even be shut down and not used for a long time. How to find this VM among hundreds or thousands of VMs and optimize their configuration is often a time-consuming and labor-intensive task. Now, we can solve this problem through the VM resource optimization function. With just some simple configurations, our system can quickly find those targets, such as zombie VMs, long-term shutdown VMs, etc., thereby helping administrators quickly optimize the configuration or recycle these VMs. We also offer intelligent data recovery. When facing disk failure causing replica loss, our system will automatically trigger data recovery to rebuild new replicas. During this process, our system will automatically detect the I/O of the application and adjust the data recovery rate accordingly to ensure that data recovery will not affect the stable operation of this business. In contrast, many other storage products only provide a fixed data recovery rate, which is very inflexible. Addressing failing or failed disks, automatic detection and isolation are very helpful. Our system uses algorithms to identify unhealthy or failing disks and automatically trigger the isolation and data recovery. During this process, administrators do not need to do anything. They only need to remove the faulty hard drive through the web UI after the data recovery is completed. Detection and isolation also applies to fail-slow networks. By monitoring the health status of network ports in real time, the system automatically detects any underperforming network ports and isolates them to prevent any negative impact on the overall cluster's performance. This helps in avoiding performance downgrade caused by a single port or host that is experiencing network anomaly. We have also provided the network topology features with Cloud Tower. This feature visually displays the relationships between virtual networks, virtual distributed switches, virtual bridges, and physical network cards. When encountering physical link failures, administrators can quickly identify all affected VMs through this panel and handle the problem accordingly. To improve the observability of the entire hyperconverged system, we also introduced a feature called traffic visualization. It offers real-time monitoring of traffic across the clusters and displays them on the UI, which makes it easy for administrators to understand and analyze network traffic patterns, as well as identify and troubleshoot network issues. With overview, topology, and list views, administrators can quickly access traffic statistics and flow information within the cluster, allowing them to promptly detect any abnormal traffic and resolve issues efficiently. Next, let's move on to features regarding migration. I'm sure that many of you have already used our agentless migration tool released previously, which allows you to seamlessly migrate VMs running on VMware ESXi to SmartX native virtualization platform ELF. It supports a wide range of mainstream operating systems and can significantly reduce the VM downtime through full and incremental migration methods. And now, we are bringing the migration tool to the next level. We just released SmartX Cloud Move, a migration tool that supports more platforms and helps migrate data from other virtualization platforms, physical machines, and public cloud hosts to SmartOS cluster. It's an agent-based migration tool that replicates and migrates data via CDP technology and is compatible with all major Windows and Linux operating systems. While the migration tools can help us tackle the majority of data migration tasks, they cannot cover all of the situations encountered. If the source host is running in an environment where the network is disconnected from the SmartOS cluster, or if we want to import some cloud host images obtained from the OS vendors, we can also use the VM import and export feature. Currently, we support importing images in OVF, QCOL2, or RAW formats to help administrators quickly launch VMs that have operating systems already installed. We also support the DIS feature. By continuously monitoring the CPU and memory usage of the VM, the system will automatically migrate the VM when its performance is affected. Users can also set the policy to manual execution so that the VM's migration will be carried out after administrator's confirmation. Through this function, resource balancing within a hyper-converged cluster will be automatically performed, thus significantly saving administrators time. As for networking, we released Everroot Load Balancer that runs within a SmartOS cluster and can provide load balancing services for applications such as virtualization, containers, or physical machines. It's purely software defined with no hardware dependencies and offers high concurrency and high availability through a distributed architecture. If you have some web-based or microservices applications, it's definitely worth trying out. Finally, let's come to SmartX Kubernetes service. Nowadays, we tend to run stateless applications in containers, while stateful applications like database still remain in VMs. That's why we have SKS. It allows you to create and manage Kubernetes workload clusters, along with the necessary compute, storage, and networking resources for them. With SKS, you can easily manage both stateful and stateless applications in one cluster. SKS makes provisioning Kubernetes workload clusters incredibly simple and straightforward. With just a few configurations and clicks, administrators can quickly deploy Kubernetes clusters inside virtual machines. In addition, we also offer features like Kubernetes upgrade, cluster scaling out, faulty nodes auto replacement, monitoring, logging, and image registries, which greatly simplifies the work of managing Kubernetes clusters. SKS workload clusters currently run within SmartX ELF virtual machines, with the compute and storage resources provided by HCI cluster. Additionally, we offer the Everroot container plugin, which not only provides basic CNI functionality, but also enables network connections between virtual machines and containers. Therefore, if you have a web application with its web server and API server running in a container and a database in a virtual machine, using ECP will make it much easier and more direct to set up the network for this application. That's all the key highlights of our product updates. To summarize, with these new products and features, we've significantly enhanced the capabilities of virtualization, networking, security, and operational management in our hyperconverged infrastructure, and greatly improved the storage performance. By supporting GPU card, we can better assist users in building the infrastructure for AI applications. And finally, with the SKS, we enable users to run and manage both virtualization and container workload on a single infrastructure. That is the end of my presentation. Thank you all for your time and engagement.
Thank you, Edward. Now, let's welcome Muyuan to give us some demonstrations of SmartX HCI's new exciting features.
Dear guests, welcome to our product demo. My name is Muyuan, pre-sales engineer over here from SmartX. My job is basically in charge of promoting the product and is handling the technical stuff in the international markets. It's my great honor to showcase our latest software-defined networking and Kubernetes solutions developed in-house. In order to give you a better understanding of the features of those products, we have designed 4 use cases. Now, let's officially begin the product demo section. The first use case, I'm going to show you the VM label-based access control provided by Everroot. I assume that all of you are very familiar with the 3-tier web application architecture. So in this scenario, we have a client that interacts with the web server and a database that stores and manages information for the web application. The VMs are grouped into 3 rows, and each with its corresponding label. So I need to emphasize one point. When more virtual machines are given the same label, they will also be controlled and governed by the security policy. Now here is the rule for each group. The client can only access the web server via TCP port 80. The web server can only access the database with the allowed port 3306. And the client does not have any access to the database. Here are the VMs used in this demo. We can see the detailed information here, including the VM state, resource usage, IP address, and the labels. And it's pretty easy to edit the VM labels. So just select one VM. And from the pop-up window, so you can delete the label, attach a label, or create a new label. So VM01 is the client with IP address 101. VM02 is the web server with IP address 102, and the VM03 is the web server with the IP address 103. So before I enable the security policy, let's do some tests. This is the client VM. So let's pin the web server and the database respectively. And I will try to connect to the web server via port 80 and connect to the database via port 3306. So from the result, we can see both VMs are pinnable and it's able to access the web server via the port 80 and connect to the database. We will do the same test on the database VM. We get the same result. All right, so let's check out what happens once I enable the security policy. Go to the network and security module. I will firstly enable the custom security policy, which is called client web server DB. Then enable the global security policy. Default rejection communication. And it's really helpful that each security policy can be presented visually here. So let's do the test again. On the client, we pin web server and database again. So the client failed to receive a pin reply. So the web server is accessible as expected. And let's try to connect to the database. So it's blocked by the security rule. Let's jump to the web server. The pin request also failed, but it can connect to the database as expected. Since the security policy is defined based on the label of the virtual machines, it will remain effective regardless of any changes in the VM's IP or physical location. So let's do another test. So I will migrate the VMs to the different hosts and say if the security rule still remains the same. So the database VM is currently on the host 112. Migrate to the 111. And also migrate the web server VM to another host. Wait for a moment until the migration completes. I will do the same tests from the VM01. So from the result, we can see the security policy still remains consistent. In addition, there is a more extreme situation. So when a user's virtual machine has been compromised, so how should we deal with the cyber attacks? Everroot micro-segmentation technique provides granular policies that restrict lateral movement and prohibit malicious behavior. So administrator can put the abnormal VM into the quarantine mode to block all egress and ingress traffic. So let's take a look. So let's put the VM04 into the quarantine mode. And open the terminal. Try to pin other VMs. It's blocked. And we can try to pin this VM from the client VM. It's blocked as well. Therefore, this approach allows us to conduct a more comprehensive analysis of the virtual machine and proceed with the recovery and the restoration operations. In this section, I will showcase the load balancing features of every route. A load balancer evenly distributes network traffic among multiple targets, enhancing the availability and resilience of your applications. You can add or remove computer resources without disrupting the flow of requests to your applications. This flexibility enables you to easily adjust to changing requirements. Moreover, every load balancer provides the option to set up the health checks. These health checks monitor the status of targets, guaranteeing that requests are only routed to the ones that are functioning properly. Let's turn to the use case. In the SmartX OS clusters, I have created a load balancer with virtual IP address 192.168.7.16. Its listening port is TCP/80, and the routing algorithm is set to round robin. The round robin load balancer forwards the client requests to each server in turn. Behind the load balancer, there is a server pool consisting of 3 web services. Meanwhile, I also set the response content on the 3 servers. So this is server 1, this is server 2, and this is server 3. So this will help us laterally to verify the load balancer function. So on this page, we can see very detailed information about load balancer and the server pool. So including the protocol, the listening port, net model, and the server pool information. So based on the above configuration, one client sends a request to this load balancer, so which we refer to as a virtual service. The client should expect to receive responses from 3 different web servers in a specific sequential order. This ensures that the workload is evenly distributed and that each server has a fair share of the requests. So to quickly verify this, we can perform a test from VM04. I keep sending requests to the virtual IP address with the port 80. We can observe and confirm that the expected result is achieved, which indicates that the load balancing mechanism is functioning as intended. And as you can see, this concept is relatively straightforward, but plays a very crucial role in optimizing the performance and the reliability of the services. Okay, let's move on to the next demo, the SmartX Kubernetes service. SKS is a newly released product this year. Therefore, I will focus on introducing the product functions and interface layout to you. Additionally, I will demonstrate the functional characteristics of persistent volume through a simple use case. So here are some features of SKS, so you may briefly understand them. For example, the multiple Kubernetes clusters with different versions, unified management of VMs and containers, flexible cluster expansion and upgrade, abnormal node replacement, performance monitoring and log query. It's worth noting that when used with every route, the network plugin ECP can be used to achieve interconnection between virtual machine networks and pod networks in a flattened manner, and also provide security access controls based on macro segmentation between pods or between pods and the virtual machines. When enabling the SKS service on SmartX OS, so the first step is to deploy an SKS management cluster. This cluster's only purpose is to create and manage the workload cluster. The workload cluster is the actual Kubernetes environment where your containerized applications are running. So in this environment, we can see we have 3 workload clusters. On this page, the users can easily understand the information of the workload clusters, so such as the virtual IP of the control plane, the number of nodes, the Kubernetes versions, and the resource allocation. Users can also see which plugins are currently enabled and whether they are functioning properly. To enable or disable a specific plugin, simply go to the settings and click the respective button. So here we also have the load balancer, ingress, and the storage CSI plugin. We can easily create a Kubernetes clusters using the graphic interface. So simply fill in the configuration information as promoted on the page. So the first is the basic information, then the node configuration. The last one is the network configuration. Then the SKS will handle the cluster creation with all the specified settings. This eliminates the need for manual operations that can be very tedious and prone to errors. The cluster expansion is very flexible as well. So there are 2 ways to scale. The first, increasing the number of nodes. So under the node group tab, so we can adjust the number of nodes for both control plane and the work nodes. The second way is to scale by creating a new node group. The advantage of using node group is that containerized applications can be classified based on their types and the resource requirements. So for example, the database applications can be deployed on the node group 1, while AI applications that require GPU can be deployed on node group 2. Once the workload cluster is prepared, so it should be provided to the end users for running containerized applications. So for each workload clusters, you will find the download kubeconfig icon. By importing the kubeconfig file into a client that has kubecontrol installed, you will be able to interact with and manage the clusters. So next, I will demonstrate how to utilize the persistent volume via command line for a very basic use case. So let's consider the following scenario. We have a BusyBox pod that needs 5 GB of storage to store the data permanently. The administrator specifies the necessary storage using the persistent volume claim and indicates the storage class responsible for handling the PVC request. This storage class will automatically generate the required persistent volume and send it to the provisioner for processing. I have already downloaded the kubeconfig file on VM04. Let's check it out. Now I can manipulate the workload clusters. This is a YAML file for the persistent volume claim. So here, we define the access mode as the read-write many, the capacity as 5 GB, and the storage class as the SmartX ELF as a driver, so which was provided by the SKS by default. After applying the YAML file, the PV will be automatically created. So we can use the command line to check this. Here it is. So you can also view this PV from the interface. It's called PVC Alpha 5. Now, let's create the BusyBox pod using another YAML file. Here is the contents of the YAML file. So this pod will utilize the persistent volume PVC L5 with the mount point set to elf vol. Afterward, I will make some changes in the pod by creating a new file under the elf vol directory. I will create the pod first. Okay, the pod is ready now. So get into the elf vol directory. Let's create a new file called test. And then I will delete this pod. That's what the file well. It's important to note that the persistent volume is a separate resource object that can store data persistently. So it exists independently of the pod and will not be deleted when the pod is gone. So to demonstrate this, then I will use the same YAML file to create a new BusyBox pod. Okay, still processing. Okay, it's ready now. Let's navigate to the elf.vol directory. See, you will find that the file test still exists. So this entire process illustrates how SKS provides the persistent storage services for the containerized applications. And certainly, if you prefer working with the UI operations, so you can also interact with the interface to create and utilize the persistent volume. Okay, this is all for today's content. I hope today's demo can give you a deeper understanding of our networking and Kubernetes solutions. So feel free to approach me with any further questions after the presentation. Thanks for your time again.
This is the end of today's webinar. Thank you for your participation. You can find out more about our products on our website and on our social media accounts. You're also welcome to join our Slack community to keep updated on our products and market progress. It's also where you can find community support. Thank you, everyone. Have a nice day.